Let's back up for a second. How do you find the x-intercept of a rational function? Or any function, really? What'd I say? That's to find the vertical asymptotes. What now? So we have no square roots. So everything's rational. Isaac, did you say something quietly so I couldn't hear it? Guys, finding x-intercepts for every single function is exactly the same.
Oh, you put y, like the 0 thing.
Yes, you set the function equal to 0. So if I set, and when you set a fraction equal to 0, remember that when we clear fractions, like if I multiply both sides of this equation by x squared plus b, this will cancel and the right side will just remain 0 because 0 times anything is still 0. So it turns out that setting a fraction equal to 0 is the same as setting its numerator equal to 0. But you don't have to remember that to remember how to find it. You could just set the fraction equal to 0 and you get to that same point by clearing fractions. So what's my x-intercept? Solve for x. Uh-huh. Uh-huh. Which means this is not the right function, right? Because our graph does not go through 0, 0.
Which means that it should be the second one because it has to be small over big, right, for it to be the 0 for the horizontal asymptote.
So we haven't gotten there yet. We're going to go through and do x-intercepts for all of them first, and then we'll look at all the rest of the stuff. So another reason that this one could be wrong is that it has it has a y-intercept, right? Because if the x-intercept is 0, 0, then the y-intercept is 0, 0, right? Because the y-intercept is where x is 0 and the x-intercept is where y is 0. If they're both 0, it's the same point. So, and our function doesn't have a y-intercept, and so seeing that this one does have a y-intercept would be another way we could see. So we're going to list all the reasons it doesn't work, although on the test or homework you only have to list one. So let's keep up with our x-intercepts. What about the second one? What's the x-intercept there? Writing something down might help.
Is it 0 still?
How do we find the x-intercept of a function?
7 equals 0.
Yep. So if a times x minus c equals 0, that means that x minus c is equal to 0 because we know that a is not equal to 0, right? Which means x is c. Well, that works. Yeah? It's positive, and there's only one of them, which is exactly what we want. What about the third one? What's the x-intercept there? It's negative c, good. So that's not right. What about the last one? What?
Would it be negative 6 still?
Did you solve the equation?
Because why don't you just do x plus c?
Did you solve the equation?
No.
It'd be the square root of c.
Did you write down the equation and solve it?
I did it in my head.
Write it down and solve it. You're not writing. Right, so what's that tell us? That there is none, right? If x squared plus c equals 0, then x squared is equal to negative c, which is impossible because any number squared is a positive, right? X squared is always positive. So we know which one is right. We know it's the second one. But it's not always going to be that simple that the x-intercept will eliminate 3 of them and leave you with just 1. So we're going to go through and look at the other components just to see how we could use those to eliminate 1 or more if the x-intercept didn't do it for us. So if the x-intercept only eliminated 1 of the functions and we had 3 that could work, then we'd have to move on to the y-intercept. Does the second one have a y-intercept? How do you know? On the second one? How'd you find it? Right, if the x-intercept is 0, 0, then we know the y-intercept is 0. How do we know?
Well, there's not supposed to be.
There isn't, well, because we know the answer, yes, that's true. If we didn't know the answer, how do we know there's no y-intercept?
Just set x as 0.
Right, we plug 0 in for x, which gives us what?
It gives us a 0 on the bottom.
Yes, it gives us division by 0, right? 0 in the denominator. So, one thing about really any math problem is always just asking yourself the right questions. So if somebody says, what is the y-intercept? Then the first thing you should think is what? X is 0, yes. So like, when I ask something like, what's the y-intercept? I don't expect you to just be able to stare at it and figure it out. I want you to think, oh, that means x is 0. Put your 0 in, and then you can get it, right? So, like, you don't have to be able to look at these and, like, know what they are. There's a process for finding everything, right? So what about the third one, or sorry, the fourth one? What is the y-intercept there? Oh, I'm sorry, we are on the third. What's the y-intercept of the third one?
A times c over b.
Mm-hmm. Right, if x is 0, then 0 plus c is c times a. And we don't have to write down what that is, because all we really have to write to prove that this is not the correct function is that it has an x-intercept. Or sorry, a y-intercept. Right, so like, it's kind of messy and ugly what that y-intercept is, but that doesn't really matter. We see that it's positive and that it exists, which immediately tells us that it's not the right function because our function does not have a y-intercept. What about the last one?
A times c over b.
Yeah, it's also a times c over b because x squared, or 0 squared is the same as 0, right? So the only difference between the bottom one and the top one, or the third one and the fourth one, is that x squared. So this one also has a y-intercept. Okay, I want you guys to write down a reason that all 3 of those are wrong based on the vertical asymptote. which you can do by finding the vertical asymptote of all of them. What's the vertical asymptote of the first? Okay.
That there is none,
There is none. Why?
because x squared does not equal negative b.
Right, x squared plus b will never be 0, because in order for it to be 0, x squared would have to be negative, right? So this one has no vertical asymptote. What is... So vertical asymptotes occur where the denominator is 0. So if x squared plus b was equal to 0, then x squared would have to be negative b. And x squared is always positive, right? Because any number squared is positive. So that's impossible. Good. What about the second one, vertical asymptotes?
Negative b.
Mm-hmm. And? How do we solve that equation? Factor, right? So x equals 0. Good. So both of those are good, right? Because when we look at our vertical asymptote, we have x equals 0 and x equals a negative. What about the third one? What's my x or my vertical asymptote?
X equals b.
Good. So x equals negative b, yes. So like this is one where we're like, oh, it has a negative vertical asymptote, and so does my graph. But why is that one not correct?
0 is not negative b.
Right.
0 is not negative.
It only has one vertical asymptote, right? So it doesn't have a vertical asymptote at 0. It only has the negative one. So this has only one vertical asymptote. Whereas on our graph, we have 2. What about the last one? And again, whoops, 1. What about horizontal asymptotes? What's the horizontal asymptote of the first one?
So y equals 0.
Yeah, because the degree of the top is larger than the degree of the bottom, right? So that doesn't eliminate that function. What's wrong, Kendall?
You said the degree of the top is bigger.
I'm sorry, the degree of the top is smaller than the degree of the bottom. Thanks. What about the second one?
And that'd be y equals 0 too.
Yeah, because again, the degree of the top is smaller than the degree of the bottom. What about the third one? So you're thinking along the right lines because, right, what's the leading coefficient of the top though? A. So A divided by 1 is A. So Y equals A. Very good. What about that last one? Yeah, it has no horizontal asymptote because the degree of the top is bigger, right? So no horizontal asymptote. So if you were completing this problem on homework or on a test, you could say this or this or this, this, this or this, this or this to give your justification for why those ones are wrong. And you don't have to give all of those reasons, just one of them is fine. But we never know which one you'll need, so that's why I went through all of them, so we could just see what that looks like. What I would do is go through and do the x-intercept for all of them and then cross out the ones that don't work. And if you have more than one left, do the y-intercept for all of them and cross out the ones that don't work until you've narrowed it down to just one function. So that way you don't necessarily have to find all 4 things for all 4 functions. You can do it kind of by process of elimination. Okay, so let's go through procedure for graphing. I'm going to actually, in the interest... So once we have all of these things, we have to think about the possibilities of what our function can do. So let's just look at kind of a general example. Let's suppose that I found that I have a vertical asymptote here. And I found that I have a vertical asymptote here. And an x-intercept there, an x-intercept there. And then a horizontal asymptote here. So first thing you want to think about is that you have to have something happening. When you draw this graph, you're going to have to draw a curve in each one of the regions between your vertical asymptotes. So you're going to have to think about what the graph looks like here, what the graph looks like here, and what the graph looks like here. None of those can be blank because this function is defined for every single x value except where the vertical asymptotes are, which means that there's a point on the graph everywhere except where those x or vertical asymptotes are. So, and again, this you want to don't try to look at it and know what the whole thing looks like. You want to think about it region by region. So if we just look at the region on the left, a horizontal asymptote tells me that as I move to the left, my function is getting closer and closer to that line. So there's only 2 possibilities of what my function can look like on the left side. Either it's approaching that line from the top or it's approaching that line from the bottom. So my left arrow has to be one of those 2. And then when we look at a vertical asymptote, we can never cross a vertical asymptote, which means that it either has an arrow going all the way up or an arrow going all the way down. So either I'm going up to infinity to the left of that, or I'm going down to negative infinity. You can't have an arrow that just randomly points towards the interior of a function. It has to either point all the way up or all the way down. So this gives me only 2 possibilities for what my function can look like. Either it looks like that, or it looks like that. Which one is it? It's got to be the one on the bottom, right? Because I have to go through my x-intercept. And if it was the one on the top, that x-intercept would just be never touched, right? So I can determine which one of the possibilities it is by the points that I know. Why can't it be both? It wouldn't be a function, yeah. So remember, you can't have more than one point for the same x coordinate. So we can't have like two graphs in the same region. Okay, so now let's think about the middle region. Well, the horizontal asymptote doesn't apply in the interior of the graph. So the only things we know is that to the right of my vertical asymptote, I'm either going to infinity or I'm going to, whoa. Sorry, I just zoomed. Or I'm going to negative infinity. And to the left of the other vertical asymptote, I am either going to infinity or negative infinity. So there's like four choices here, right? I could go from top to top. I could go from top to bottom. I can go bottom to top or bottom to bottom. Well, let's see. If I use this bottom arrow here, then I would have to be able to get up to this point. Is that okay?
No, because it doesn't have to cross the x-intercept first.
Well, that's over there. I haven't gotten there yet. But I know what the x-intercepts are, right? Is there one at negative 2.8? So the key here is, and what's going to help you with the majority of these, is that you cannot create new points, right? If you find all of the x-intercepts, then those are the only places you can cross the x-axis. You can't cross the x-axis somewhere else because otherwise you would have found that x-intercept when you found the x-intercepts. So if that arrow on the bottom were part of my graph, it would create an x-intercept that I don't have. And so I can eliminate that. Which means now I am either going like this or going like this. And I mean, we can kind of tell by which one looks better, which one it is. But since we don't want to rely on that, both are a possibility, right? I could come down through my y-intercept and then bounce off my x-intercept and go back up. Or I could come through my y-intercept and then down through my x-intercept. And so when you're not sure, then you need another point. In this case, we have no function, so I'm just going to make up a point. Whoops, not right there. But if you were really graphing a function, you would plug this number, that x value, into the function and just figure out if you're up top or on the bottom, so if it's positive or negative. So in this case, this has to look like this. And then on the right side, there are two possibilities for what happens at the vertical asymptote. So to the right of the vertical asymptote, and there's two possibilities for what happens at your right arrow. So draw your arrows for those four possibilities. Can you figure out what the curve has to look like there? Did you draw your arrows? So does everybody have that? So which one is it? Is it going to be like this? Or is it going to be like this? It's the top one. Why? Yeah, we can't create an x-intercept, right? That doesn't exist, which means that's a no-go. So we kind of have to use process of elimination, just knowing how functions behave at their asymptotes. And then sometimes you'll have to plug an x value in just to see which possibility it is, so just to narrow it down a little bit more. But you shouldn't have to like make a huge table and plug in a bunch of x values. It's like tops, you maybe have to plug in 2. So let's do a couple of these. So graph, so the last step to this is graph using the above plus the behavior at asymptotes. So at a vertical asymptote, to the left, it's either up or down, and on the right, it's either up or down. And there is no correlation between them. Like it could be up, down, down, down. Like it's not like they have to go the same direction or anything. And then at a horizontal asymptote, and remember this is only on the edges, on the exterior. You can't have like arrows in the middle of the graph. So if I have a horizontal asymptote, then I either have an arrow here or an arrow here. And then on the right, I have an arrow there or an arrow there. So this is a little bit different than when we've graphed in the past, because in the past we come up with points and then draw a curve through them and throw arrows on the ends. Whereas here we're kind of starting with our arrows, so starting with how the function behaves at the ends and then filling in the interior. So if you guys want this whole thing, go ahead and take a picture of it if that's helpful.
Plus?
Yes. Here, I'll make it an and sign if that helps.
Oh, it's and?
Well, kind of means the same thing. What's retinoblastoma?
Eye cancer. I get more blind every day.
Oh, I get more blind every day too.
It's ridiculous.
I swear, like our eyes, like if you have eyes that like don't work, they like when you adjust your vision, your eyes are like, no, I'm not supposed to see, and they just adjust it right back because at the end of every year, I feel like I can't see, and then I go in, they're like, oh, you need stronger contacts, and then I can't see, and I go in, they're like, oh, these ones are too strong, like every year. I'm just blind.
My
As a
glasses
bat.
just get so scratched up that it's like not even worth wearing them because you can't see anything.
Totally. Oh no. Okay, do we all have it?
I just wrote it down under the original.
Oh yeah, that's fine too. Whatever works for you. Okay, so let's graph a couple functions. So let's graph f of x equals 2x squared minus x minus 6, 16 minus x squared. In the interest of time, I'm going to do all of the preliminary stuff for you, because that's all stuff you guys did last night on your homework. So -1, x plus 4, x minus 4. So our x-intercept or intercepts are -3/2, 0, and 2, 0. My y-intercept is 0, -3/8. I have a vertical asymptote at x equals -4 and one at x equals 4. And I have a horizontal asymptote at y equals -2. I found all those just using what we learned yesterday. So let's put those on our graph. My vertical asymptotes. Always use dotted lines for your asymptotes because they're not actually points on a graph. It's an 8, yeah.
Okay, cool. I'm telling you what.
I used to not wear my glasses, but I have to start doing that.
And then I have a couple points here, -3/2, 2. And then like that -3/8, like we're not concerned with it being perfect. It's between 0 and -1 somewhere. It's like right there. That's as exact as it has to be. Okay, so just like we did on the last one, we're going to look at the region on the left, the region in the middle, the region on the right. So on the very left, I have to approach from top and bottom. And then here it's either up or down. So I have two possibilities. Either this one or this one. Which one is it? Yeah, it's got to be the bottom because I am not allowed to create an x-intercept, right? And be sure you erase your, like the ones that aren't correct, so you don't have like random arrows just float around. Okay, and then in the middle, up or down, up or down. So, well, if it was, can it be the up arrow here? Is it possible for me to go like this?
Yes.
That works. The other doesn't work, right? There's no way I can go through this point and then get back to this point without crossing the x-axis. Yes?
Really stupid. Could you go from like the top arrow all the way to the other top arrow?
Totally.
Okay.
Yep. And in fact, in this case, that's what we have to do because, again, on the right side, if I went through this, the only way to get back there is to cross the x-axis again. So both of them have to be going up.
So you have to hit your x-intercept first.
What do you mean first?
I'm like, I guess I'm confused because so when you go from top to bottom, you have to hit the x-intercept and then you can't go back down. Like you said, you could go like from the bottom, from the right bottom.
Mm-hmm.
You can't do that.
Well, because we have to go through this point.
Yeah.
And then we also have to go through this point,
Oh, okay.
right? And that would create another x-intercept.
Oh, okay.
You could make it a point if it only touches one point.
Yeah, you could. I mean, this could go like this. I think that I'm not going to give you one that's that, like, tricky,
You
I
haven't
guess.
learned that math yet.
Well, I mean, it's not that you haven't learned it. Like, I could come up with a function that you could graph that ends up looking like that, but I feel like that's just, like, making it more complex than it needs to be. You know, like, let's do some simple ones, and I'll give you a challenge one maybe at the end. Go crazy. Okay, and then the last one, draw what you think it is. That region on the right. We all have it? So this guy's gonna look like that again, right? Because the other possibility goes through the x-axis. Okay, let's look at one more. This one will be quick, I promise. We're gonna do where is it? F of x equals 4x squared over x minus 3. So this one has an x-intercept at 0, 0, which means that the y-intercept is also 0, 0. The vertical asymptote is x equals 3, and there is no horizontal asymptote. So, I mean, this is the kind that, like, when I do this kind, I'm like, oh gosh, this sucks, because that gives us very little information, right? Like, We know that there's a point here, and we know there's an asymptote here. And that seemingly doesn't tell us a whole lot. However, the fact that there is not a horizontal asymptote means that the arrow on the left and the arrow on the right have to go to either positive or negative infinity because they're not approaching another value. Like if there's no horizontal asymptote, they're not approaching a specific value, which means either we're going up here or we're going down. And then the same is true right here, up or down. Now that still doesn't help me out a ton because I could connect any two of those arrows and go through that single point. And this is where sometimes you just have to plug in a couple numbers. So when you plug in numbers to figure out what the shape is, you want to plug in numbers between your pair of arrows and the x-intercept, and then between your pair of arrows and the x-intercept. So I'll plug in -1 and 1. And I'll just tell you what I get. You guys could get the same thing, just put it in your calculator. So and really, I don't care what those exact points are. What I really care about is whether or not they're positive or negative. So if they're above the x-axis or below it. So here we have a point here. I'm sorry, I got rid of this guy. And then, so we've got this one and this one, which means which two arrows do I have to use? The bottom two, right? Because in order to get to the top, if I'm going through those 2 points below the x-axis, in order to get to the top, I would have to cross the x-axis more than once. So, and these ones look kind of funny, the ones that don't have horizontal asymptotes. And then on the right side, same deal. Up or down here, and then up or down here because there is no horizontal asymptote. So my right arrow has to go to infinity or negative infinity. And here I have like no points whatsoever. But that actually helps me more than that single point because it either has to be both top arrows or both bottom arrows because I can't cross the x-axis, right? So I can't go from top to bottom. So I'm going to plug in one number. And I think I end up, it's like 60 or something. It's something big and positive. But I don't care what it is. I'm not going to actually plot that point. All I really care about is that it's positive. Because that tells me that my entire graph is above the x-axis. So it has to look like this. Make sense? Okay, so tonight you guys have written homework, but know my